In this lesson, I want to talk about in-context or top-down modeling. These two names are used interchangeably in SOLIDWORKS, and they both refer to creating parts within the context of the top-level assembly. There are several parts in this assembly that were created in context. We can see some of these if we open up the feature manager a little bit, look down through the parts. Some of the parts are going to have a symbol after the name of the part. This symbol is the minus sign and greater than sign. So the front cover, the hoses, and the wires are going to be created in context. Now it's easy to see why some of these parts are created in the context of the assembly. The alternative would be for the parts to just be created in their own window and then placed in SOLIDWORKS. And the main difference between the two is that a part like this hose has a very specific shape, and this shape only makes sense in the context of the assembly. The hose has to connect to the compressor, and the compressor has a certain spatial orientation. And then the hose also has to connect to the intake manifold, which also has a certain position in space. The position in space for these two components is determined by mates in the assembly and the other components. And then the hose is created using the edge from one part and the edge from another part. So if these parts were to move in the assembly, this hose would flex to move with them. Let's take a look at some of the internals that go along with in-context relations. If we look at this part on its own, we see that the hose is actually made up of two separate hoses, and each one of these features was created in context. The symbols are easier to see here when they're separated from the rest of the symbols in the Assembly Feature Manager. And if we click on the plus to expand that, we see that each one of these sketches, the 2D sketch and the 3D sketch, have their own in-context relations. Let's look into this even further. If I open the sketch and edit this, you see we've got a sketch entity that's black, which means fully defined, but we don't have any sketch dimensions. So we must have some sketch relationships. Let's take a look at the relationships in the sketch. And there's only one, and you can see that this sketch relationship has an in-context symbol on it as well. This circle was created by using convert entities on a part that was outside of the existing part in the assembly. So as I was working on the hose part, I clicked on an edge of another component. Now we can look into this even deeper and see what that other component is if we look in the entities box. We can expand this somewhat so we can see everything. Arc3 from an external model is driving Arc4 from the current sketch. So we have an edge of a part called turbo, which is in the assembly called engine for motion, and the current part is called hoses. The assembly is located here at this path. If you want to remove an in-context relationship, you have to come here and delete the on-edge relation. There are other types of sketch relations that can be in context, and even dimensions can be in context, where a dimension goes between some item from another part and an item in the current sketch. That's the relationship of sketch 1. The relationship of sketch 2 is a little bit more complicated. We look at this again, we see we have multiple in-context relations. We have a coincident at one end and a tangent, and then a tangent and on plane on the other end. And these are from different parts. We look at this. The on plane is using the face of the intake manifold, while the tangent is tangent to an axis in the turbo component. So SOLIDWORKS is keeping track of all of these relationships. Most of this keeping track is transparent to users, although you do need to know about which parts relate to which parts. Let's go back into the assembly and pose a hypothetical situation. Let's say that the intake manifold has an in-context relationship with the engine block, which it does because the angled faces of these plates need to have a reference. And then maybe this cover has a relationship to the engine block as well, which it doesn't in this case. And then possibly the turbo had a relationship to the cover. And then the hose has a relationship between the turbo and the air intake. What we've got here in this hypothetical situation is what's called a dependency loop, where this part depends upon this part, which 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 depends upon that part. Changing one part might cause all of them to change. And in fact, they might continue changing with every rebuild. So part A is referenced to part B, and part B is referenced to part A. This is the sort of relationship or circular relationship that you need to avoid when creating in-context relations in SOLIDWORKS.